let's talk about how input sanitization should work in an application like this. So here's what's happening at present. We've got an attacker, and that attacker is going to send a request to the web server that looks like this. So this is what we saw just before, and clearly this is a SQL injection attack. As we now know, the web application is going to take this query string parameter and it's going to make it look like this particular statement. Now, because of this OR 1 equals 1 tautology, the database is going to return every single record back to the web application, and the web application is going to spit it all back out to the attacker. Injection attack successful. But let's do this. Let's scroll all this back and we'll imagine that the website is now actually sanitizing the input. So it's going to look at this query string parameter, so the untrusted user data, and it's going to decide whether this is valid or not. Now this to me doesn't look valid. And we just talked about the reasons why. So in this case, it's not just a V and then an integer, or even just alphanumeric and spaces. It doesn't conform to a valid pattern for cylinders. So with input sanitization in place, it's going to do this. Rejected. That's all. It's that simple. And it's just a matter of the web application saying, hey, this is not a good request. It doesn't conform to one of those allowable patterns I just explained. So getting back to the sort of things that you want to be looking for as an ethical hacker, let's go and have a look at a whole bunch of different character ranges that you should think about for testing input sanitization. Here are some good examples of characters that are often used in SQL injection attacks. We've seen some of these already, so things like single quotes and dashes and equal signs. Many of these are used to mount an attack. There are also a whole bunch of others that we haven't looked at. Things like percentages that are often used in like clauses, the @@ syntax to access server variables. All of these are the kinds of things that you want to test for when you're establishing what sort of sanitization is going on in the app. Now you'll see I've also got regex patterns in here for A through to Z, both lowercase and uppercase, and for numbers. Now that's not to say you should never use letters because they could be involved in a SQL injection attack, but it's about establishing what is allowed by the app. Because in many cases, you are only expecting an integer, particularly when things like an ID is passed. The application shouldn't be allowing letters. That would not pass what should be a whitelist rule that says only give me numbers. So this is a really good character set to start using. Now sometimes you'll see that I've got double characters, so the @@ syntax for example. The web application may legitimately need to accept the @ symbol. Email addresses are a great example of that. But does it need to legitimately accept the @ symbol? Now I'm a little bit pragmatic here, and I want to be cautious about recommending that an application should be too overzealous in its whitelisting, because the last thing you want is to make the application unusable. There are many examples of problems like folks in Ireland not being able to register on a web application because of the prevalence of a single quote in the surname. That's the last thing you want. Well, other than a SQL injection attack, it's the last thing you want. But it is the sort of thing you want to test carefully to determine what sort of characters you might be able to use in an injection attack.